All right, we are up to grouping to count arrangements. So we're looking at ordered selections and three more principles. So we're going to use grouping to arrange, to count arrangements. We've got 4 boys and 4 girls form a queue at a bus stop. So one queue. One couple wants to stand together. So we are going to assume that that is a boy and a girl. Okay, it doesn't actually explicitly state it, but then it says the other 3 girls and the other 3 boys. So the couple is a boy and a girl. All right. So one couple wants to stand together, the other 3 girls want to stand together, but the 3 boys don't care where they stand. How many acceptable ways are there of forming the queue? So, like we said, we're going to deal with what we've got. Okay. So with the constraints. So what we're going to look at though is we're going to use groups. So one of the groups we're going to have is we're going to have, we'll call it G1 at the moment, and we'll call it BG. It's terrible. BG. Okay, so that's our first group. It is the boy and the girl. That is the couple. Cool. Then the next group, group 2, would be the 3 girls. Cool. So that's now sorted. Then there's the 3 boys, but they don't care where they stand. So they are actually group 3, group 4, and group 5 is a boy, and a boy. The reason we keep them separate is because they don't have to all be together. They are individuals that don't care where they stand. So we have 5 groups. So now if we treat the groups as though that was the way we're doing it, we can work it out from there. So we're going to order the 5 groups. So if I just took these 5 groups, how many different ways can I organize those 5 groups? Well, I can do it 5 factorial. So that is ordering, can't spell. Ordering, I still can't spell apparently. Ordering the 5 groups. Okay, ordering 5 groups. That is 5 factorial. Okay. Then the next thing we'll do is we'll go, okay, well, now that we've got these 5 groups in order, so those whole blocks are now in order because there's 5 factorial ways that we can organize those groups. Now, within those groups, I have to organize these guys. How many different ways can I organize those 2? And this is where it actually gets simple because we'll go, as long as I can spell ordering the couple, there's only 2 of them, so they can be organized 2 factorial ways. And then the last one is ordering the girls group. And there's 3 of them, so they can be organized 3 factorial ways. So main thing was we ordered the groups first. We went, right, let's bunch them as groups because we know these 3 want to stay together. We know these 2 want to stay together. So we treat them as though they're a blob. And we order the 5 groups. So 5 factorial ways to order those groups. Then we go back and go, okay, I don't care where the boy and girl are placed. We know they're the same, but the boy could be in front and then the girl, or the girl could be in front and then the boy. So there's 2 factorial ways that we can order them. Then with the group of 3 girls, you've got girl 1, girl 2, girl 3, or it could be girl 1, girl 3, girl 2, or it could be girl 2, girl, you know what I mean? And there's 3 factorial ways of doing that. So our grand total is going to be 5 factorial times 2 factorial times 3 factorial, which when you put it into the calculator, you will get 1,440 different ways, acceptable ways of organizing that queue. Well done, us.